video, we're going to use completing the square to solve quadratics. This is what we're going to start with. If you remember, when we were completing the square, we had a squared term, we had the linear term, but we did not have a constant. So in this case, we're going to take the constant to the other side by addition. So if we add the 51 to both sides, we will have a squared plus 14a equals 51. Now notice I did leave a space here. Give yourself room to work. That way I have a space to put the number that I'm going to add. So what do I need to put on both sides? You're going to take half of the 14, that's 7, and then we square it. So I'm going to add 49 on both sides. That means on this side, I'm going to have a plus 7 squared equals, and 51 plus 49 is 100. Now this is what I need to solve. You can do that. The reason we learned how to complete the square is because if you have a perfect square on one side, you can take the square root, and you can take the square root of the other side. Now this one works out very nicely. We end up with a plus 7. And you know the square root of 100 is 10. However, I chose to take the square root of both sides. So you do have to remember that not only does 10 squared equal 100, but negative 10 does also. So whenever you put the square root in, you have to include a plus or minus. So this is plus or minus 10. So then, when I decide to solve for a, I need to subtract 7 from both sides. You have to realize that a equals either 10 minus 7 or negative 10 minus 7. Well, 10 minus 7 is 3, and negative 10 minus 7 is negative 17. So I had to squeeze it in here, but those are my two solutions. And that's why we learn to complete the square so that we can solve a quadratic. Let's look at a couple more examples. For this next problem, we have n squared minus 2n minus 3 equals 0. Now remember, if we're completing the square, we need to take the constant, the 3, to the other side. We can't just take it there. We have to do it mathematically, so we will add 3 to both sides. And when we do that, that will give me n squared minus 2n equals 3. Now, what am I going to add to both sides? Take half of that and square it. Half of 2 is 1, and if I square that, I just have 1. So I now have n minus 1 squared. Don't forget, we always use that sign. Equals 4. Since I have a square on one side, I can take the square root, but this is going to give me a plus or minus on the right. So I now have the square root of n minus 1 squared is n minus 1, and that's going to give me a plus or minus 2. So I'm then going to add 1 to both sides, so I will have n equals 2 plus 1, which is 3, or n equals negative 2 plus 1, which is negative 1. So those are my solutions to this quadratic equation. N can either be 3 or negative 1. Let's look at another one that's just a little more difficult. Let's look at k squared minus 4k plus 1 equals negative 5. Again, we don't need the plus 1 on this side, so we're going to take it to the other side. And that's going to give me k squared minus 4k equals negative 6. We really don't have to worry about what's on the right-hand side. We're trying to make the left-hand side the perfect square. So we're going to take half of 4, which is 2, and when we square that, we'll get 4. So we're going to add 4 to both sides. That will now give me, on the left, k minus 2 squared equals, and on the right-hand side, I end up with negative 2. Now, this is where we take the square root of both sides. The square root of k minus 2 squared is simply k minus 2. And I didn't write it in the previous step, so don't forget you're going to get a plus or minus here. And it's going to give me plus or minus. Now remember, we've got a square root of a negative number over here. That's going to give us an imaginary number. And I included this in this section because I know in your other math class that you will be working with imaginary numbers if you haven't run across them already. So whenever you've got a negative underneath the square root, you have to take out the I. So this is plus or minus I times the square root of 2. You cannot simplify the square root of 2, so we're just going to leave it like this. This is another place where you don't want to change that to a decimal. For one thing, you would be coming up with an approximation if you changed it to a decimal. So there's no reason to approximate it. That is an exact answer. Then we're going to add 2 to both sides. And for our final answer, that's going to give me k equals 2 plus or minus I square root of 2. And that is your final answer. You cannot simplify that anymore. So I said it might be a little more difficult. The only thing that made this problem more difficult was you had a square root of a negative number. You just had to bring an I out. And then when you add the 2 to both sides, it can't be simplified, so you just put it in there like that. It is possible, I'm not sure about your instructors, they might want you to write this out so that you show that it is 2 separate solutions. To do that, it would simply be 2 plus I square root of 2 and 2 minus I square root of 2. And that would be something that your instructor would tell you if that's how they want you to write it. We're going to do one more example, and this example is k squared minus 12k plus 23 equals 0. I'm not sure why this worksheet seems to like k's for their variable. It doesn't really matter. Same as before, take the 23 to the other side, and we have k squared minus 12k. We need to take the 23 to the other side. In this case, since it's positive, we are going to subtract 23 from both sides. So that will give us k squared minus 12k equals a negative 23. Complete the square. You're going to take half of 12, which is 6, and square that, you get 36. And that's what we're going to add to both sides. Now, this you write as a perfect square. That's k minus 6 squared equals, and when you subtract those, you end up with 13, or combine them. You're going to take the square root of both sides. That gives you k minus 6. And this is going to give you plus or minus the square root of 13. Should put a plus or minus there. Add 6 to both sides, and that gives you k equals 6 plus or minus the square root of 13. There is one more problem that I want to do, and this problem is a little bit different because it is going to have a number in front of the squared term. Uh, 5x squared equals 60 minus 20x. Take the 20x to the other side. You need to have the x squared by itself. For this problem, you can divide the entire equation by 5, as long as you do the same thing on the left as you do on the right. So that's going to give me x squared plus 4x equals 12. Half of 4 is 2, and square it, you get 4. X plus 2 squared equals 16. When I take the square root of both sides, I end up with x plus 2 equals plus or minus 4. And when you subtract 2, you have 4 minus 2 is 2, and you have a minus 4 minus 2, which is a negative 6. And that is your final answer. I might have said that was going to be our last problem, but we're going to do one more. Because we're having so much fun with this, why not? 3x squared equals negative 4 plus 8x. We need to take the x over to the left this time. So that's going to give us 3x squared minus 8x equals a negative 4. Okay, so what do we have to do? Well, we have to factor out the 3. Eight divided by 3 is 8/3. Now, don't look at that too difficult. That's too difficult. Let me do it over here. 8/3 times 1/2. 2 goes into 8 4 times. That's 4/3. And then I have to square that. That's going to give me 16/9. So that's what I'm going to add. So I'm going to add 16/9. Now, one thing you have to pay attention to, that 16/9 is being multiplied by 3. I'll erase this when I'm done, but 16/9 times 3. 3 goes into 9 3 times. That is 16/3 is actually what I've added over here. The 16/9 being multiplied by 3 gives me 16/3. So that means, and I've got a lot of extra work here that I need to. That means if I had a minus 4, I'm going to add 16/3 to that. So here I have 3 times, and this is going to give me x minus, and that was 4/3 squared, equals, what's that going to give you? Multiply 4 times 3 over 3. 4 is the same as, but it's a negative. That's the same as a negative 12/3. What's negative 12/3? It's the same as negative 4. When I combine those, that gives me a positive 4/3. That's what I have on this side. How are you going to solve this? Well, you've got to get rid of the 3, so we're going to divide both sides by 3, which is the same as multiplying by 1/3. And I'm kind of running out of room, so I'm going to go up here. When I divided those out, I have x minus 4/3 squared equals, and that gives me 4/9. Take the square root of both sides. This gives me, I'm going to have to get rid of this. This gives me x minus 4/3 equals, you take the square root of the top and the bottom. I told you that often with these problems, the fractions work out really well. We end up with plus or minus 2/3. And we're going to add 4/3 to both sides. So x equals a positive 2/3 and a positive 4/3 is 6/3. 6/3 is the same as 2. A minus 2/3 and a positive 4/3 is simply 2/3. A negative 2 and a positive 4 gives me a positive 2. So that is the final answer. We ended up with 2 and 2/3 as our two different answers. Make sure there's a comma in there. It's not a mixed number. There was a little bit more involved in this one, but you can do it. Just take it one step at a time. And when there's a number out front, whatever you add has to be multiplied by that number so that you know what to add to the other side. Practice these. It is a good way to solve a completing the square. Usually, if it's your choice and your teacher doesn't tell you which method to use, usually you would probably do completing the square when the middle term is even and there is not a number in front of the x squared. And I would always try to factor before I did a completing the square.